Hello students, mathematics problem solving session. This is lecture number 1 and our topic is matrices and determinant. I will continue. We expect you to have a basic background on matrices and determinants to follow these lectures. So although I'll topic before starting a problem solving session and properties of matrices and determinants. Let A be an M cross N matrix defined by A is equals to A1 to A2n AM1 AM2 AMN. So this is how we define a matrix. Okay. In short, we write A as a square bracket Aij. Okay. Then let's define the transpose. Transpose of a matrix A is denoted by A transpose AT, and it is defined by interchanging the row and the column. That means A transpose is equals to A11 A12. Up in the first column is replaced by first row A1n. Similarly, the second column is replaced by the second row 21 A22 A2n AM1 AM2 okay. So when equals to n, n cross n square matrix okay. Then A is said to be symmetric if A transpose is equals to A. Okay, so that is Aij is equals to Aji, right, for all I j. Okay, similarly then again we say A is symmetric if A transpose is equals to minus A. This implies Aij is equals to minus Aji for all I and j. This implies aii is equals to minus aii implies aii is equals to 0 for all I. Okay, so implies diagonal property matrix. So for example, if C is a scalar, then C times A is defined as a C into Aij. Scalar by a matrix, then each into each. Transpose, or not necessarily the square transpose square one, but you take any two matrices A and B. A plus B transpose is same as the A transpose plus B transpose, and product of two matrices and its transpose is same as B transpose into A transpose. Okay, so let's define another notion which is called the determinant of matrix. Okay, determinant so determinant of matrix is a scalar quantity and it is defined for a square matrix. So let A be an n cross n matrix, then determinant of A is a scalar quantity. Okay, and then we also denote determinant of A by A. You just put two parallel lines and put matrix A inside that. Okay, so let's define this. Okay, so suppose if when n is equals to 2, so the A is represented by A11, A12, A21, A22, then determinant of A, okay, is defined by A11 to A22 minus A21, A12. Okay, when n is equals to 3, then A is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, then how do we define the determinant? So determinant of A, so I will use both the notation, either the A with two parallel lines or just the determinant A. So this is defined by, we just take the first row, okay, and take the first element A11, then we get the submatrix by deleting the first row and first column, and then we calculate the determinant. So A22, A23, A32, A33, then minus A12, the second one, and then we delete the first row and the second column, and whatever the submatrix we get, we just write it here, A21, A23, A31 and A33. Okay, plus A13, the third one, and then we delete the first row and the third column, and we get the following submatrix: A21, A22, A31, A32. Okay, so this is how we calculate a determinant of 3 cross 3 matrix. Similarly, we can find a determinant of any n cross n matrix. So here I took the first row to expand it. We can use any row and any column, but only thing is this multiply, this the sign of these multipliers like a11, a12, a13, it's defined by the following. So sign of aij is given by the sign of -1 to the power I plus j. So if I plus j is odd number, then there will be negative sign, otherwise it will be a positive sign. Okay, so for example, I mean, we can compute the determinant by any by taking any row and any column. For example, if a is, let me just write once, a11, a12, a13, a21, a22, a23, a31, a32, a33. Okay, so suppose instead of a first row I take the third row. Okay, third row if I take, then I can write the determinant of a is equals to the first element of the third row is a31, and the sign will be positive because 3 plus 1 minus 1 to the power 4 is 1, so plus sign. So we take the first element a31 and delete the third row and the first column, and we get some matrix a12, a22, a13, a23. Then we take the second one a32, and this sign will be negative because 3 plus 2 is odd number 5, and then we delete the third row and the second column. We get a11, a13, a21, a23, and then the third entry a33. 3 plus 3 is a even number, so I'll delete the third row and third column, and we get a11, a12, a21, a22. So in a similar way we can calculate the determinant of any matrix by considering any row and any column. Okay, all right, so let's see some properties of determinant. So I'll list out some important properties of determinant which will be useful while solving the problems related with determinant. So first one is the determinant of A is equals to determinant of A transpose. Second is if any two rows or columns of a determinant are interchanged, then sign of determinant changes. Third one, if all the elements of a row or column of A are 0, then determinant of A is 0. Fourth property, if any two rows or columns of a matrix A are identical, then determinant of A is 0. So some more properties. Fifth one, if suppose in a determinant, in the first row we multiply with the same constant k of a12, k of a13, 22, a23, a31, a32, a33. Suppose we encounter the determinant, so this determinant can be written as a k times the determinant of a11, a12, a13, a21, a22, a23, a31, a32, a33. Okay. So the sixth property, if suppose we have the following determinant a11, a12 plus x, a13, a21, a22 plus y, a23, a31, a32 plus z, and a33. This determinant can be written as a sum of two determinants. First one is a11, a21, a31, a12, a22, a32, a13, a23, a33. This is the first one. Then plus the second one is a11, a21, a31, x, y, z, a13, a23, a33. So this is how we break this first determinant as a sum of two determinant. Okay. So seventh property. Okay. So it is a product of two matrices, determinant of a product of two matrices. Suppose A and B both are square matrix, okay, of order n. Then determinant of AB is a determinant of A into determinant of B. Okay. So these are the some properties. One more important property. Let me just list it. For example, what is the determinant of C times a matrix A, where C is scalar? So this is nothing but C to the power n determinant of A, given A is a n cross n matrix. Okay, so yeah, so these are the some important properties of determinant. If some more properties are used, then I'll explain when I solve those problems. Okay, so let me introduce one more concept in matrices. It's called the inverse of a matrix. Okay, so let A be n cross n matrix, then its inverse is defined by A inverse is equals to adjoint of A divided by determinant of A, where determinant of A is non-zero. Okay, so this means A inverse exists only if determinant of A is not equals to 0. Okay, so we call invertible matrix as non-singular matrix. We call an invertible matrix as non-singular. This is another name, non-singular matrix. Okay, so we know how to calculate the determinant. So now what is the adjoint? So adjoint of A, this is nothing but the transpose of cofactor matrix. Now the question is, what is cofactor? Okay, so let me explain all these things with the 3x3 matrix. Suppose A is a 3x3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so what is the adjoint of A? So if I write adjoint of A, I just write it as A11, A12, A13, A21, A22, A23, A31, A32, A33. So where this Aij's, this is the Ij cofactor. Okay, and so this matrix, so adjoint A is nothing but the this is a cofactor matrix, and you just take its transpose. Okay, now the question is, how do we compute these cofactors? Okay, so in general, this Aij is nothing but minus 1 to the power I plus j into determinant of submatrix obtained by deleting ith row and jth column. For example, A11 is the 1 cofactor which is obtained by deleting first row and first column, and this is the determinant. This is defined as a determinant of a submatrix obtained by deleting first row and first column. So what do we get? We get A22, A23, A32, A33. So this is how A11 is defined. Similarly, we can define, let's say, the other AIJs. So let's see what is A12. So A12 is nothing but you delete the first row and the second column. So you get A21, A23, A31, A33, and here it will be multiplied with the minus 1 to the power 3. So this is the minus sign. So similarly other AIJ can be calculated. So to find the adjoint A, we just first calculate all these cofactors, and then we form a cofactor matrix and take its transpose. That will be the adjoint of A. Okay. So now we know how to calculate the inverse of a matrix. Okay. So there is one important. So there are two properties related with the inverse. So for example, first one is the determinant of A inverse is equals to 1 upon determinant of A. So how do we get it? A inverse is equals to identity matrix. Then the determinant of A inverse is equals to determinant of I, which is equals to 1, and I is identity matrix. Alright. Then this is nothing but determinant A into determinant A inverse equals to 1 implies determinant of A inverse is equals to 1 upon determinant of A. Okay. So now another one is the related with the adjoint. Determinant of adjoint A can be obtained from the determinant of A, nothing but n minus 1. So where A is n cross n matrix. Okay, here A is n cross n matrix. Okay, yeah. So this also this is also not very difficult to prove. Okay, so yeah. So I think these are the more or less the properties which we will be using when we solve the problems related with determinant and matrices. So let's solve the question number 1. Let M be 3 cross 3 matrix satisfying M times 0 1 0 is equals to minus 1 2 3. M times 1 minus 1 0 equals to 1 1 minus 1. Third one is M times 1 1 1 equals to 0 0 12. Okay, then what will be the the sum of the diagonal entries of M. So let's solve this problem. Okay, so suppose M is given by this M11, M12, M13, M21, M22, M23, M31, M32, M33. Suppose M is given by this. Okay, then we need to find the value of M11 plus M22 plus M33. Okay, so let's see how to do that. Alright, so we take the first equation. First equation says that M times 0 1 0 is equals to minus 1 2 3. So this implies if you multiply M matrix with the 0 1 0, then you will get here you will get M12, M22, M32. This is equals to minus 1 2 3. This implies M12 is minus 1, M22 is 2, M32 is 3. Okay, so let's take the second equation, which is M1 minus 1 0 is equals to 1 1 minus 1, and this implies if you multiply M with the 1 minus 1 0, then you get M11 minus M12 M21 minus M22 M31 minus M32. This is equals to 1 1 minus 1. So this implies M11 minus M12 is 1, implies M11 is equals to 1 plus M12. M12 is from here, if you see minus 1, so it's 1 minus 1 0. So M11 is 0. Now, so this is the first entry of a diagonal. This is the second diagonal entry. Okay, so okay, let's see another equation. M21 minus M22 is equals to 1. So this implies M21 is equals to 1 plus M22. So 1 plus M22 is 2 is equals to 3. Okay, and the last one is M31 minus M32 is equals to minus 1. Alright, this implies M31 is equals to minus 1 plus M32. What is M32 is 3. 3 minus 1 is 2. Okay, so now, yeah, so these are the these are the values we have. So now let's go back to the, because still we need to calculate M33, the last equation. So last equation is 1 1 1 is equals to 0 0 12. So this implies that M11 plus M12 plus M13, M21 plus M22 plus M23, M31 plus M32 plus M33, this is equals to 0 0 12. Okay, so from previous slide I think I know the value of M31 and M32. Yes, M31 is 2, M32 is 3. Alright, then let's take this equation, third one, M31 plus M32 plus M33 is equals to 12. So M33 is nothing but 12 minus M31 minus M32. And what is M31? Let me just see from the previous one. M31 is 2 and M32 is 3. 2 plus 3. So 12 minus 2 minus 3, it is 7. So we get M33 as a 7. Okay, so this means M11 plus M22 plus M33 is nothing but M11, if I remember correctly, it was 0, M22 was 2. So 0 plus 2 plus 7 is equals to 9. So this is the final answer. Question: let W not equals to 1 be a cube root of unity and S be the set of let me just write and S be the set of all non-singular matrices of the form one A B W1 C W square W1, where each of ABC is either W or W square. Then what is the cardinality of this S? Okay, so let's solve this problem. Okay, so answer, okay, given S is a set of all non-singular matrices, then the determinant of this matrix, determinant of 1 A B, this matrix is not 0 by the definition. is not equals to 0. So let's see what is the determinant. So this is 1 into 1 minus WC minus A times W minus W square C plus B times W square minus W square not equals to 0. This implies 1 minus WC minus AW 1 minus WC not equals to 0. This implies 1 minus WC into 1 minus AW not equals to 0. So this implies 1 minus WC not equals to 0 and 1 minus AW also not equals to 0. Okay, so now, so this is the condition we got. Okay, so now there are another condition, so which is W cube is 1 and A and C can take only W or W square. Okay, so given W cube is equals to 1 and 1 minus WC not equals to 0, so this implies that A not equals to W square, C not equals to W square, because if A and C are W square, then 1 minus WC will be 1 minus W cube, which is equals to 0. So that means only possibility for A and C, therefore A is equals is W. So A is W and C is W. This is the only possibility. Okay, so now what can we say about the B? So B we can take, whereas B can be either W or W square. Okay, so now let's form a set. Let's form a set S. S is the set of all these type of matrices. So AC is fixed, 1 A is W, and in place of B, first I can take W, then W1 C, in place of C I can put W, W square, W and 1. Another can be when B is replaced by W square, 1 W W square, 1 W W square, and W1 W W square W1. So these are the possible set of matrices. Okay, so this means what? S can have only 2 matrices. This implies the cardinality of S, also denoted by this mod. Let me just write it as cardinality. Is the number of elements in S. This is equals to 2. So this is the final answer. Okay, so let's solve another problem. The question is, let P equals to Aij matrix be a 3 cross 3 matrix, and let Q is equals to Bij, where Bij is equals to 2 to the power I plus j, Aij, where this I and j are between 1 and 3. So it can take value 1, 2, 3, right? The integer quantities. Okay, so if the determinant P is 2, then what will be the value of determinant of Q? Okay, so let's solve this problem. So first let's form a Q matrix. So what is a Q matrix? Okay, right. So let's find the determinant Q. Okay, so determinant Q is equals to this 4a11, 8a12, 16a13, 8a21, 16a22, 32a23, 16a31, 32a32, 64a33. Okay, now take the 4 common from the first row, 8 from the second, and 16 from the third row. 4 into 8 into 16, then we have a11, a12 2 times, and 4 times a13, a21, 2 times a22, 4 times a23, then a31, 2 times a32, and 4 times a33. Okay, so again we can take 2 common from the column 2, 4 from the column 3. So this we can write 2 square, 2 cube, 2 to the power 4, and then you can take 2 common from the column 2 and 4 from column 3. So now we get a11, a12, a13, a21, a22, a23, a31, a32, a33. Okay, so this is equals to, this is the determinant of P, right? 2, 3, 5, 9, 10, 12, 2 to the power 12 into determinant of P, and we know that determinant of P is 2. So determinant of Q is equals to 2 to the power 12 into determinant of P, which is 2, equals to 2 to the power 13. So this is the final answer. Question: let P be a 3 cross 3 matrix such that P transpose is equals to 2P plus I, where I is the 3 cross 3 identity matrix. Consider a column matrix which is also called a column vector X and XYZ, which is not equals to 0. That is, we are considering a non-zero vector X. Then which of the following is true? So the first option is P of x is equals to 0, 0, 0. The second option is Px is equals to x. The third option is Px is equals to 2x, and the fourth one is Px is equals to minus x. Okay, so let's solve this problem. Okay, so let's start with the what is given to us, which is the P transpose is equals to 2p plus I. Let's call this equation 1. So take transpose on both sides. That means P transpose, let me just erase this, P transpose of transpose, this is equals to 2p plus I transpose, and this is nothing but P is equals to 2p transpose plus I transpose, which is I itself. Let's call the equation 2. So now what is P transpose minus P? This is equals to 2 times P minus P transpose. Alright, so this implies that 3 times P transpose minus P is equals to 0, and this 0 is the 0 matrix. Okay, the matrix which has all the entries 0. So this implies P transpose is equals to P. So that is P is a symmetric matrix. Okay, so now given P transpose is equals to P, then from equation 1, if you see P is equals to 2p plus I implies P is equals to minus I. Alright, so this is what we obtained. Okay, now let's check which options are true. Okay, so the first one is Px is equals to 0. This implies that P is minus I, so minus Ix is 0, 0, 0, and this gives x as 0, 0, 0. Okay, but x is given to be non-zero, so this implies 1 is not true. Okay, the second is Px is equals to x. For Px is equals to x, and then this implies that P is minus I, so Px is minus x is equals to x. This implies that x is again 0, and here 0 is this is a 0 vector, but x is non-zero, right? This big zeros, I mean, they denote the 0 vector, right? So that means 2 is also not true. Okay, similarly 3 is also not true, because 3 will also lead, 3 is satisfied only if x is 0. So similarly 3 is not true. Okay, then the fourth one. So fourth one is that Px is equals to minus x. So this is true because Px is equals to minus x. So this is true because P is minus I. So we can say that for all x not equals to 0, 0, 0. So 4 is true. So out of 4 options, only the last one, the fourth one, is correct, because other 3 are satisfied only if x is equals to 0, but x is given that it's non-zero. Okay students, so I'll stop here now. I'll solve some more problems related with matrices and determinant in the next lecture. Thank you.